The next topic is electrocardiogram. So the electrocardiograph records the electrical activity of the heart by picking up the movement of ions in body tissues. And it does not measure action potentials, although action potentials certainly result from the depolarization that we do detect in the electrocardiogram. So we can measure we can see the depolarization and repolarization in the electrocardiogram. We cannot see the action potential, but we know it's happening from the depolarization and repolarization. And the other thing that we can't see, but we know is happening, is the contraction and relaxation. We can't measure that in the electrocardiogram, but we know that's happening as a result of these depolarization and then repolarization events. So what do these waves mean? So the P wave is an indicator of atrial depolarization. The PQ interval is the period for atrial systole. Okay, so if we say atrial in front of systole, that means that the atria is contracting. If we say atrial diastole, that means the atria is relaxing. If we just say systole and diastole without putting the word atrial in front of them, it means we're talking about ventricular systole and diastole. So the default setting for those words is to refer to the ventricle. However, we can sometimes use them for the atria if we put the word atria in front of it. So atrial systole is atrial contraction. Atrial diastole is relaxation of the atria. Okay, so again, the P wave is atrial depolarization. The PQ interval is the atrial contraction or atrial systole. The QRS wave represents ventricular depolarization. And then the ST fragment represents ventricular systole. And then it turns out that the T wave represents ventricular repolarization. And I want to show that over here as well. And again, just want to go over this again. So we have the P wave being the atrial depolarization. The PQ interval is when the atria contract. We have the QRS wave, which is the ventricular depolarization. And then this ST segment represents ventricular systole or ventricular contraction. And then the T wave represents the repolarization of the ventricle. We can't see the repolarization of the atria because it's invisible due to the strength of the depolarization in the ventricle. And you can see the ventricle has a much stronger depolarization than the atria do. And then I want to show you that in the ventricles, we see, I just want to show you that the action potential, as I showed you, is a very slow action potential, right? The depolarization happens quickly, but the action potential is actually much slower than in skeletal muscle due to the slow nature of the calcium-mediated depolarization, giving this unique plateau. So I just want to show a little bit more about this. So here we have the P wave, right? That is the atrial depolarization, right? And then the contraction for atrial contraction happening here, right? And then we have the QRS, which is the depolarization of the ventricle. And then we get the ST portion, which is the contraction, right? And then at the end, we have the repolarization of the ventricle, and then relaxation over there. And I want to show you what's cool here. We can actually see these events in color in the work with the parts of the heart. So let's go. I showed you on the graph over here, and I want to show you. Okay, So depolarization of the atria, P. Yellow is depolarization, right? That's being depolarized, okay? Then we're going to see, though we can't see, I told you that the QRS wave, which is the depolarization of the ventricle we see here, and then although we don't see it on the ECG, there is indeed a repolarization of the atria that occurs. Okay, that happens. We just can't see it, but it's happening because the QRS wave is so dominant. We don't see that. Okay, but we can see the depolarization of the ventricle, and in the end, we begin to see that T wave is the repolarization of the ventricle. I want to show you now a little bit more about the heart, now correlating the ECG, pressures, and heart sounds. Right, so what we see up here is the pressure in the ventricle in millimeters mercury. And then we see the ECG waves down here and the heart sounds, okay? So during systole, which is ventricular contraction, this is going to follow the depolarization, the QRS, of the ventricle. The QRS is going to happen, it's going to depolarize. Remember, it's that slow depolarization thanks to the calcium mediated depolarization following the sodium mediated depolarization. And we're going to see this contraction of the ventricle, right? And that's going to occur during this ST wave. And we're going to see as it's contracting, the intraventricular pressure is going to rise. And that means when it gets over 80, right, which is the pressure found in the aorta, the blood in the ventricle is going to be ejected into the aorta, right? And as it does, the pressure is going to be coming down and then releasing. And then we know that the semilunar valve is going to close as the pressure in the aorta becomes higher than the pressure in the ventricle. Right? So the ventricular pressure is falling, and then with the semilunar valve closing, what happens? That's happening at the same time that we have the repolarization of the ventricle. And then I forgot to mention what happens in the beginning is the AV valve is closing. So when we have the QRS wave, which is the depolarization of the ventricle, what's happening is that the AV valve will close, right? And the tricuspid and bicuspid valves are going to close, and we can hear that, and that's going to be overlapping with the time of the depolarization. So basically, the A valve closure is going to overlap with the depolarization of the ventricle, and then the semilunar valve's closing happens to overlap with the repolarization of the ventricles.